In this presentation, we are going to find the number of moles of two compounds. I'm going to ask you the question, and then you are going to take a couple of minutes to solve the question on your own, and we are going to explain the solution and find the correct answer together. How many moles are there in 1.7 gram of ammonia, NH3? Given the relative atomic mass of nitrogen is 14 and the relative atomic mass of hydrogen is 1. So take a couple of minutes and try to solve this first question on your own. One of the golden but simple rules in chemistry is that the number of moles is equal to mass over the relative formula mass. So the number of moles in ammonia is the mass of ammonia, and that is given, that is 1.7 gram, over the relative formula mass of the compound. We've got the numerator, 1.7 gram, but we still have to find the denominator, the relative formula mass of ammonia. Well, that is equal to the number of nitrogen atoms in ammonia times the atomic mass of nitrogen plus the number of atoms of hydrogen in ammonia times the atomic mass of hydrogen. So we summed up the relative masses of all the constituents of ammonia, and that is 1 nitrogen atom and 3 hydrogen atoms. That is equal to 14 plus 3, which is 17. So now we have both the numerator and the denominator. If we divide 1.7 by 17, the answer is 0.1. Let's see if this is correct. That's awesome! It's the correct answer and found by a simple rule, which is that the number of moles is the mass over the relative formula mass. 1.7 gram of ammonia has 0.1 moles. The second question is the same, but the compound is a little bit more complex. How many moles are there in 25.5 gram of sodium nitrate, NaNO3? Given the relative atomic mass of Na is 23, of nitrogen 14, and oxygen 16. So again, try to solve this on your own first and then continue the video to find the correct answer. Was your answer equal to 0.3 moles? Well, 0.3 moles is the correct answer. How did we find that out? First of all, again, with the rule of the number of moles, it's equal to the mass over the relative formula mass. In this question, the mass of sodium nitrate is given. It's 25.5 gram. However, what is not given and what we are going to find out and what we are going to calculate is the relative formula mass of sodium nitrate. That is equal to the sum of the masses of all the atoms that are found in sodium nitrate. Let's count them together. We have 1 sodium atom, we have 1 nitrogen atom, and we have 3 oxygen atoms. So the relative formula mass of sodium nitrate is 23, which is the relative atomic mass of sodium, and we have only 1 sodium atom, plus 14, which is the relative atomic mass of nitrogen, and we have only 1 nitrogen atom, plus 16 times 3. 16 is the relative atomic mass of oxygen, and we multiplied it by 3 because we have 3 oxygen atoms in sodium nitrate. The answer is 85. We didn't find the number of moles yet. we have to divide the mass, 25.5 gram, by the relative formula mass, which is 85. Dividing them will give you the answer, which is 0.3 moles. So 25.5 gram of sodium nitrate contains 0.3 moles of the compound.